Okay, example 1, we're supposed to graph y equals 2x minus 1. And first off is recognition of a slanted line from its equation. Okay, first of all, our directions are to graph, which tells me that so far up until now, graphing's been on a number line, right?
Yeah.
Lesson 50, we graphed points, plotted points. That was on a Cartesian coordinate system like this. Has an x-axis and a y-axis. Okay, make sure, first of all, for graphing anything at this point, graphing lines specifically, we use graph paper. We put a vertical axis, label it y. We put a horizontal axis, label it x. Make it look like this before you start graphing points. Okay? You don't put the x and the y. I don't know how to read your graph, especially if you staple upside down or something weird like that. So put the x over here to the right, put the y up to the top, so I know exactly how to position your graph. If it gets turned some weird direction, I don't think I can turn this. Oh, I can. If it gets turned like that, I still know that that's x, that's y, so I would flip it back that way to be able to do it. Okay? So my directions here are graphs, so I'm going to graph. And what makes this slanted? What I see that makes it slanted is y and x are both in it. They're both to the first power.
You got mail.
Okay. If I see both x and y, they're both to the first power, it's always going to create a slanted line every single time. Alright? That's the only type of graphing we're doing in this class until like lesson 108. So from this point to lesson 100, it's 100 and something, but it's up to around 108. Until we get to that point, every time it says graph, it means to graph a line, unless it says specifically graph on a number line. Alright, if it just says graph, it means a line. If x and y are both there, it's a slanted line. Once you see it's a slanted line, your first priority is to make it look like this, y equals everything else, which right now that's what they're all going to look like, y equals everything else. The next time we visit this will be in lesson like 54, 55, somewhere in there. They're going to make you have to rearrange it first. We've already been doing that. Solve the following equation for y. We've been doing that. They're going to make that the first step. All right? But at this point, we're right where we need to be. Y equals everything else. And all we have to do to graph this is we pick some x values. Now, going back to this little recipe I've got that I've given out to you, pick some x's and place them in the chart in the x columns. If x is being multiplied by a fraction, pick multiples. Okay? No fractions in this one, right? So the directions say pick some x's. This is you picking whatever numbers you like to pick. I'm not going to try and influence you in any way, shape, or form. Pick whatever numbers you want. Just know you have to graph them. So if you pick 72, you have to count out to 72. All right, my personal preference is I pick numbers near 0. That's what I usually do. So I would pick maybe 0, 1, and 2. I also like to pick things in pattern. Okay? You don't have to pick them in pattern, but if you do, it tends to make things a little bit easier to deal with. Now, I kept y highlighted for a reason. Okay, the y column of my chart is determined by using the x value I picked in my x column and transferring that into the equation to get the y coordinate. So these different colors here just to see where things are coming from. All right. This says x equals 0. How did I come up with x equals 0?
You made it up?
I just made it up. Okay? The x coordinate is called independent. Independent. It can be anything you want it to be. It's an independent variable because whatever you feel like is there. If you're having a bad day, maybe you pick 6.23. Because you're having a bad day, you just want to make it harder on yourself. If you're having a great day, maybe you pick 2 because 2 is easy. All right, but whatever. You pick whatever you want. All right. Y is known as the dependent variable because its value depends upon x's value. So this is the equation, this is the rule that tells me how to find y off of x, and it tells me very clearly to get y I'm going to do 2 times x minus 1, and our first x is 0. So I simply put 0 into the equation for x because 0 is the number I picked. I felt like 0 was a good number, so I threw it in there. I put it in place of the x right here. 2 times 0, 0 minus 1 is negative 1. 0 goes in, the equation occurs, negative 1 comes out. That's all an equation is. It's telling you how to find y off of the x you picked. The second y I picked was 1. Or sorry, the x I picked was 1 here. So again, I'm going to put 1 into the equation. Again, y equals 2x minus 1, x is right here, x is what I know, which equals 1. I work that out. 2 times 1 is 2 minus 1 equals 1. 1 goes in, 1 comes out. The third number I picked was 2. X equals 2. I put 2 into the equation. So y is going to equal 2 times something minus 1. The something we're putting in is 2. 4 minus 1 equals 3. 2 goes in, 3 comes out. Every x you pick, you put into the equation to find out what y goes with it. That's all you have to do. You're creating ordered pairs. Every one of these ordered pairs are going to lie on the same line. We simply plot the points. Just like we did in lesson 50, x equals 0, y equals negative 1. That means I start here at the origin. I don't go left to right at all. I go down 1. My next point is 1, 1. From the origin, I go right 1, up 1, put a point. Next point is 2, 3. Start at the origin, 2 to the right, 3 up. Notice the 3 points I have line up nice into a straight line. Final step is to get a straight edge. And connect the dots with a nice straight line. Put arrows on the ends of the line. It doesn't have to be this thick. I'm just doing it for effect. Alright, get a straight edge when you connect the dots. Put arrows on the ends of your line showing it goes on forever in both directions. Just to clue you in about, it doesn't matter what we pick for x. Those are the numbers I picked for x, right? Oops. What? Slide that down a little bit. Suppose I picked some other numbers. I don't know. Suppose I picked 3 or negative 1. Again, if I put 3 in place of that x, 6 minus 1 is 5. Put negative 1, negative 2 minus 1 is negative 3, right? 1, 2, 3, 1, 2, 3, 4, 5 on the line. Negative 1, 1, 2, 3 on the line. Let's try negative 2. Negative 2 times 2 is negative 4 minus 1 is negative 5. 1, 2, 1, 2, 3, 4, 5 on the line. You find some dots, you connect the dots. Every dot you're going to get is going to be on the same line that anybody else gets. What you pick for x does not matter. What you get for x paired with y is what matters. You get the correct y for every x. The line you get is going to be the same as everybody else's.